Now we will see about GPS module, that is Google Positioning System module. This is a Neo 6M GPS module. This is a type. Okay, here you can see that it is a Neo 6M GPS module. This is the GPS antenna, this part. Okay, you can see that this is the GPS antenna and this is the GPS module. We can get the exact GPS location like in degrees and also in minutes, seconds. In that format also we can get the readings. Okay, this is the GPS module. This is used for getting the exact location of a place. Okay, uh, this you can think of for making some emergency vehicle system. That means if my vehicle is going very fast, um, by using some ultrasonic sensor or anything, you can detect the accident, and when the accident happens you need to send the this GPS data, that means their Google positioning data to the some other emergency contact. Okay, this is the GPS module. Now here this module has four pins: VCC, RX, TX and ground. Now we are seeing this new word RX and TX, means this is the serial communication, that is the receiving the data and transmitting. Okay, receiver and the transmitter, RX and the TX. So how we have to connect this means, for this now we are not going to write the full code because this code requires something like degree to minute conversion, everything. It's I will show that code how it is. You can see this code, but I will explain. It's something huge code. So now for the time, as the time constraint, I will already wrote this code, and some part I just copied from the internet source. And what the main thing is that you no need to buy heart all these codes. Okay, if you understand once, then you can able to write the codes, and almost these codes are all available in the internet, this few of the codes. But the main thing is that some codes are working, some codes are not working. That is the main thing. All the codes are not working for this module. That means Neo 6M, this is the what I am showing is the working code. So I already checked these codes whether it's working or not, and some part I changed in this code. Okay, this part I added something, these parts like these things I added, and here I will explain. First one, we need two libraries, that is the hash include tiny gps.h, and other one is the hash include software serial.h. These two we need libraries. Then software serial, GPS software serial. Why we need this library means, this software serial.h, it will convert your RX and TX pin, that is 0 and 1 is there. No, this is your RX and TX pin. Instead of 0 and 1, we can use any other pins, any other digital pins as RX and TX. This software serial.h library has the power to convert other pins as the RX and TX pins, because these pins are there, no, 0 and 1. It will not work so many, lots of times it will not work. If you connect the GSM module, it will not work sometimes. So I don't know the exact reason for that, but by using the software serial.h, you can use any other pins as the TX and the RX. So what we will declare here means, oh sorry, I forgot to show this. Okay, here any other digital pins we can use. Okay, and no need to use this 0 and 1 for RX and TX. You can use, but if you use the other pins, here we are using the other pins as RX and the TX. Here I am using GPS software serial 4,3, means 4 is the RX. First pin we are declaring is the RX always, because alphabetical order R comes first, then the T. Okay, so this is the RX is the 4 and 3 is the TX. That means Okay, uh, this 4 is the Rx. Okay, here 4 is the Rx of the Arduino. From this fourth pin, remember this, if any RX TX comes in any of the coding, if serial pins we used, then you have to, okay, I will show this, in any of the Arduino codes, if any serial pins comes, that means serial pins programming, then you have to remember that you have to connect TX of this module or any other things to the RX of the Arduino, and RX of any other module you have to connect it to the TX of the Arduino. That means it is transmitting the data, it is receiving the data. So here it is TX, here it is RX, and if it is RX here, then TX here. Okay, so what we declared here means, what we declared here, okay, here we declared that 4 is the Rx and 3 is the Tx. So I will connect this. Here I have to connect 4 pins, 1 2 3 and 4. Okay, now this white color is for ground. We'll connect this to the ground, and this yellow is for VCC. Okay, this is my V in or VCC I will connect. Okay, we'll make this separate, and next one is the red color, that is the TX I have to connect it to the RX of the Arduino. That means here the RX pin is 4. Okay, in the code what we are writing, it is for the Arduino. 4 is the RX pin, that means my TX pin, that is this one, red color is the TX pin. Here you can see this red color is the TX pin. Okay, this TX pin I will connect it to the RX, that is the pin number 4. Okay, then here I have the RX pin that I will connect it to the TX, that means 3 of the Arduino. Yeah, I connected. Okay, you can see I connected 2 for the one for a V in and other for the ground, and another one is the TX and the RX. Now in the code what is there, let's see. Okay, tiny GPS plus GPS, there is the naming of my GPS. Then here minutes, seconds, that means we are getting the this location in two different formats, that is one is the minutes and the seconds, and other one is the seconds, degree, seconds and minutes. No, this minutes and seconds we are used for some conversions, but we are actually getting that in like this 73 degree 32 minute 11 seconds. In this format we will get. Okay, so for that white setup, in the setup what we will write means serial dot begin, that is to just to visualize this, and GPS software serial dot begin, that means it is define baud rate for the software serial communication. Okay, these devices have some baud rate, that means for transmitting the data. This GPS has the baud rate of 9600, same as serial monitor. Okay, so I'm transmitting the data to the 9600, that means this has the capability to transmit the data in the 9600 baud rate. Okay, if we some different models have different baud rates. Okay, but from the Arduino to the computer serial monitor we can use anything, any baud rates. But for here for these modules we have to check its specifications at what baud rate it's sending, that we need to use. Then pin mode 12 comma input, this one I think we not used. Okay, this one simply I wrote because here something trigger 1 equal to digital read 12 comma input, just ignore it. This is not for this code, it is something for trigger, that means some button we used I think. Okay, then yeah, smart delay 1000, this is the function call that I wrote in the downside, that means it will generate the 1 millisecond delay. Instead of using the delay function for millisecond delay 1, it will use accurate delay, this smart delay function that I will show you. And these are all just look at these things: latitude value and longitude valid. That means whether it's valid or not. You just concentrate on these things: latitude value, longitude value. Okay, if we get the latitude and longitude, we can easily in the Google map, if you type latitude and longitude, you can get that. And you can even get the altitude in meters. Okay, altitude. Okay, here you can see here. In even the time also you can get hour value and gps.time.minute, gps.time.second, this for the time. Okay, this is time valid, that means whether it is giving the time properly or not. Here what we are doing means tiny gps.h, that library we used, we are simply here declaring, we declared some variables here. You can see those variables. Yeah, here you can see those variables: latitude value, longitude value, altitude value. You can see those things. We are simply making that latitude value equal to gps.location.lat. This is from that library. It will get the latitude data from the library. That means from that library, so that you need not to write the complete code for that. Okay, if you use that library, from that library you can easily get gps.location.lat. If you write like this, it will give the latitude value. And same as longitude value. Longitude value, get longitude data. This is not required, but it is for a good code, we can write all those things. And here, if latitude or longitude, if it is not there, that means if my location is not valid, location is valid, that means if it is not detecting, then it will print like this in the serial monitor. Otherwise, if it detected, it will print, you see, uh, deg means second of latitude value. That means my latitude value converted to degree and minute and the second. This is my function call that I wrote here. You can see that void deg minute second. Okay, this you can see. This is it will convert your those latitude value into degree, minute and the second conversion. Some mathematics we did. And here yeah, dig to min, then latitude value, we are just printing all those values: latitude in decimal degree, serial dot print latitude value comma 6, latitude in degrees in milliseconds. Okay, then here longitude. Until here we wrote latitude, and from this again we converted the longitude value to the degree, minute and second. We displayed that. That's it. It's no, code is not difficult. If yeah, here if altitude is not there, then if alt valid, that means if it is not of alt of valid, here you can see if we write the this mark at the beginning, then exclamatory mark, then it is meaning that if not, it is the not, a negation. If negation of altitude valid, if it is not valid, then print like this: altitude, just star 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 star, else print the altitude value. If time is not valid, just print the time as like this, otherwise just print the time like this. That's it. Percent to d, percent 0 to d, hour value, minute value, second value. It's a very easy code. And here it's a smart delay. This will delay for a 1 millisecond in a very precise way when compared to the delay function. Here we use something called mills is one function. This mills function, it will count the time from the starting of your program. That means it will not pause the Arduino. If you use the delay function, everything will be paused. Delay means if we use the delay function, delay 1000 means 1 second, it will not do anything, it will completely pause the Arduino. But by using the mills, we can in the work, for example, for blinking the LED for 1 second, in one side we can blink the LED for 1 second, and in the other side we can continue our other works. That's also possible by using this mills. Okay, mills function. Now we will try to compile this code. Definitely it will give error. Yeah, because tiny gps plus plus this library is not there. So we will download that library. Which is that library? tinygps plus plus dot h. Okay, so go here and here just type tiny gps plus plus library download. Okay, tiny gps. Okay, just you can download from the github or any other websites. Just click on this. Okay, tiny gps plus plus is there here, and okay, here something download this. Yeah, it will again redirect us to github. I told no, you can directly download from the github. So from this, what I will do means, yeah, think this is the source code of that. Yeah, tiny gps 1.0.b dot zip. Okay, zip file is downloaded. Now in this I will add that zip file. So include library, add .zip library, and here in the downloads we got that tiny gps plus. Okay, yeah, I will add it. Library added successfully. Now I will compare again. That means compile again. Now it is giving too many arguments to function int digital read. Yeah, I don't know. This is simply we write this. We will just delete this. I don't know why we write this also pin mode 12 comma input. Just delete it. Now we will compile it. Okay, those two lines are I think simply I wrote, just ignore it. Yeah, now it's done compiling, and okay, then we will upload this to our Arduino. For that I will connect the, yeah, I connected the Arduino. Okay, then if the software serial.h is not there, same way you need to go to Chrome and you need to search for that library, and you need to download and go to sketch and manage libraries here. Okay, include library, add .zip library, and we will upload this. Now we are uploading to the Arduino. Okay, it's uploading. It is done uploading, but actually if you see the output, definitely you will get everything as 0 0 0 0. See, this is because this GPS is not getting the signal, because I'm inside the room, it is not getting the signal. So if we go outside the room, we can see the signals. For that what I will do means, yeah, I will show that actually. Now we will go outside the room and we will see how we will get the data here. After some time we will go home because the charge is very less. Pause it.